I want to review the last problem we solved in the last session, only in 1 or 2 minutes, and then we will go and solve more difficult questions using the sliding window pattern. So the first problem, which is the base of our base to understand, what is the structure of the sliding window pattern. We have an array, and we wanna find. Let me bring my pen. So we have an array. Let's say we have 2, 5, 1, 4, 3, 6, 7. Let's say this is my array, and k is 3. And we want to find the maximum sum of all of the subarrays with size of k. What does it mean? It means that what is the sum of this guy? Sum of this guy is 1 plus 6, 8. And sum of this subarray with size of k is 6 plus 4 is 10. And you can go in this way, and the next one, which is this subarray, is 8. And this one is 9 and 4, 13. And the last one is 16. And we want to return 16 as an answer, the maximum sum. The trivial solution or brute force solution is we can go and find for each window, we can do a for loop with size of k and find the maximum. And the order will be, if we go the basic solution, will be n times k. But if we do the sliding window, we did here, we go and make our first sliding window, and we when we formulate our the algorithm, we need a for loop with window end, because window end will reach end of array sooner than window start, right? So we will start with window end. When we are going, traversing the array, we were updating our metric based on our objective of the problem, which is maximum sum. So I need a variable named window sum. And in window sum, I wanna keep the sum of a window. So first of all, I have to update it. So the first step inside of this for loop is updating the metric. And then I have to check if I have a valid window or not. If window end is greater or equal to the k minus 1, it means that we made one window. And now it's time to update my result, which is max sum. We have this, so I will update my max sum. The final objective here is max sum. Max sum will be equal to max of maximum sum so far, and actually, and the window sum, the current sum of the window. And then it's time to shrink my window. And the shrinking means increasing window start by 1. But before shrinking, I have to update my metric. So that's why we update our metric. I specify here with the yellow color. We update it here, but for shrinking, we have to update our metric because we are dropping or popping out the first item of the window. So that's why we write window sum minus array of window start. And then we can increase this. And this, the next round again, we will add the new item. We will update our window sum, and at the end we will return the maximum sum. As you can see in this method, in this algorithm, we traverse only once the whole array. That's why we say that we decrease the time complexity from order of nk to order of k. And only we had some scalar, some variables as, to calculate our, our objective. So we don't use any space. So the space complexity is actually order of 1. because, you know, this is time and this is a space. Actually, this is our answer. Okay, this was the base. Only to review previous session, and for the people who didn't join the last session, to be able to track what's going on here. So, any question for this part? Any comment? Okay. Let me check my. Okay. So let's go to the next problem, and I want to increase a little the difficulty of the question. I want to go, you know, level by level. I don't want to dive in, you know, the hard problem. So you can, you know, compare the, you know, and finally we will compare, you know, the solutions, and you will see that we have really, you know, that you will see the structure of the, you know, the sliding window in all of them. And if you remember the last session, I said we need if statement here because we have fixed size sliding window. But if we don't have fixed size, if is not enough, we will do while loop here instead of if, because we can shrink more than once. And now we will go to the next question. The next question is, we want to find the longest substring, longest substring with k distinct characters. This is one of the also the most frequently questions, but usually this kind of questions are asked in the phone interviews. If you go in the lead code also and filter based on a sliding window, the questions, you will see the frequency of this question is one of the highest frequency questions. So we have a string. Let's say we have A, B, A, Z, T in random, okay? And K is 2. We want to find the longest substring with K distinct variables. So let's go and solve this, you know, manually, because the example is really small. We want to have K distinct variables, and K is 2 here. So if I go from, you know, A to, let's say, you know, I can see that these first 4 characters includes only, you know, the A and B. So we have only A and B inside of this, A and B, and this is, you know, K equal to. I cannot, you know, increase my, you know, window more because I will have 3 distinct characters. So far, my answer is 4 because the length of longest substring is 4 so far. But if I go forward, you know, for this example, as you can see, we cannot find you know, larger than this. So we will return 4 as answer. Okay, 4 will be our answer. That's the question. We want to go and find, you know, all the substrings, and we should have only K distinct characters. So let's say we don't know this sliding window, and this is the first time we saw this problem. And what will be the trivial solution? I strongly recommend to, you know, all of you guys, and all of, you know, everyone, you know, is doing, you know, the coding interview. For every question, first of all, please do the brute force or the most trivial solution. Even if you don't want to talk about it in your mind, you should do that. Because if you do that, then you can, you know, easily convert it and optimize it. For example, right now, what will the brute force? when I start with A, I will go forward, right? And I will find all substrings. We need 2 nested for loops, right? To find all of the substrings with different lengths, right? And then we need to count whenever we go for all of these guys. We can count them, and let's say we put the frequency of each character inside of. For example, here we will have 3 and B will be 1. This is my the dictionary or hash map. I can put all of them here, but I can traverse all possible substrings. But in order to find all possible substrings in a string, we need 2 nested for loop. So it will cost us order of n squared, right? It will be order of n squared. But now we want to use the benefits of the sliding window. And what is the benefits of a sliding window? Let's say A, B, A, A. I want to write a little bigger. A, B, A, Z, T. So I want to start with a sliding window and keep extending my sliding window until it doesn't violate my objective. How can I calculate my objective? I need an extra data structure. And because because we want to know how many distinct characters we have, we can use a char frequency, right? Let's say, let's say I want to write, let's say this is my char and this is the frequency. I need to put character and frequency inside of my hash map. What else we can use? Can we use hash sets? Because we want to only track the distinct characters, right? I want to discuss a little about the solutions, because the solutions, if you search and on the web, on the Google, in Google, there are lots of solutions, lots of explanations. I don't want to dive and solve immediately. I want to discuss about the problems to show you all of the the wrong decisions, also to avoid them. Not only for this question, for similar questions, we have to learn all the wrong approach that doesn't give us the final the optimal solution. Right now, maybe let's say we can use Hashmap and put all of the the frequency of all of these. And for this guy, so if I start from A, B, A, I'm going putting all of them in Hashmap, and the length of Hashmap should be K, which is 2 here. But if it is, let's say I'm doing this here, I added all of these guys. This is my hash map so far. When I go to Z, I will add Z and 1. And now the length of my hash map is 3. It means that the last one was extra, right? And I need to, I need to remove it, or it's time to shrink my window. Let's say I go and extend my window to this, and I see that my hash map, length of my hash map is greater than K. It means that my window is not valid. So what should I do? I should shrink my window until I have a valid window. So if I shrink this guy, to this, whenever I'm shrinking, I have to update my hash map, because this is my metric. Do you remember the last question? We said our metric was only max sum or window sum. But right now, in order to handle our objective, to calculate our objective, we need a hash map. I will talk about hash set, and you will see why hash map is much more, we can handle with hash set, but it will be much more complicated. I will talk about it later. So we add Z, and we see that it is not valid window. We shrink, and if I shrink, this will be 2, right? A will be 2. It's not valid yet. I have to shrink again. It means that I need a while loop until while length of my hash map is greater than K. Because if it is greater than K, I don't have a valid window, right? So I will, let's say, shrink again. I will have this guy, the red one. If I shrink this, B will gone. So now I will have A2 and Z1. And now we have the length of my hash map is 2. It means that I have 2 distinct variable characters. So the length of this is 3. But you remember, the first window, which was this, the length of the window was 4. So we will keep 4 as our largest or maximum length. And when we reach to this, we will update the maximum lengths, but we already have larger than 3. So the max length will be 4, right? It won't be changed. And we will go in this way. So the only difference we have in this question compared to the previous one we had here, we need a while loop for shrinking, because maybe we will need to shrink more than once, right? Maybe we will need to shrink more than once. And also, instead of having only simply a window sum, we needed hash map or a data structure to update our metric. And based on this, we can calculate how many distinct characters we have. So based on the objective of the problem, which is K distinct characters, this is the requirement of our problem. You have to detect which data structure you need. Sometimes we can do this with simple variables, or sometimes we can do this, we need to do with the hash map or hash set or queue. And that's it. This is the only differences. I think everybody can right now write the code for this guy. I'm gonna go and write down the code, I prefer to type for the codes here, and then because it can be more readable for you guys. Okay, let me change my style to code. Okay, let's code. Okay. So we want to define, let's say, longest substring. I don't want to write the really accurate the function names. So we have a string and we have a K, right? We have a string and K as inputs. If you remember in the last session, we said we need window start, but window end will be handled in the for loop. And what is our objective, the result? The result is maximum length. We want to reach a maximum length. So the initial value should be 0. But when we want to reach the minimum, the initial value should be infinity, because we want to update it, in several, the iterations. And also we said we need frequency, hash map to keep the frequency of the characters. And I name, always, the hash maps, char, frac, map. I name in this way. I want to be sure based on the name, it is a map, hash map, and it maps character to the frequency. The naming is really important. Even in the interviews, one of the really important parts, is that, how you name your characters. It shows that you are, you are writing your really readable code and clean codes. And you have to write, really readable and meaningful names. I want to write in this way. Yeah, Windows start and okay. So I will compare this with the previous solution, and you will see how they are similar to each other. So we'll go for window end in range len of this. Okay, so we want to do the for loop and over the string, and for each new character we have to update our metric. Do you remember the last session? I said the first step is to update our metric. So I want to write the current char. The current char is equal to s at window end. I want to make my code a little easier to read. So I want to say the string at the index of window end in current char, and then I want to go and update my char frac map. So I will write char frac map of the current char. I want to update the frequency of this, and we know that this. Let me write here. It is char to frequency. So the index is, or key is current char, and I want to write this is equal to. I can write in a current char, current frequency char at the index of current char +1, but what if we don't have current char before, and it is the first time we want to add this? If I write like this, I want to write, let's say I'm writing like this, I will receive an error. Why? Because we don't have initially any character inside of the char frequency map. So that's why I will write this is equal to. You can write if a statement. If we don't have this, go ahead and insert this. But we have a function in Python which can help us in this way. We can use the get function. Get means if we don't have a key inside of the hash map, it can return a default value. So I want to say get the current char frequency inside of this, but if we don't have this, return 0 for me. Okay, return 0 to me, and then +1. Okay, so here we are updating our metric. As I said, update the. We don't have a space here. Let me. Update the metric. And here our metric is a hash map. So if we don't have current char already, it will be 0 + 1, it will be 1. And this is exactly what we want. But if we have already a variable, it will be added, we will add by 1. So after this, we need to, if you remember, I said in the previous question, we said we need if a statement to check if our window is a valid window. We want to update our, the metrics and our objective. But here, as we talked about it in this, in the solution, we need a while loop, because maybe, so when I'm going forward and I'm adding window end, maybe I go more than I need. And my, let's say here, we increase the size of window end is here. If it is here, I have to shrink it. But I want to go first and do, let's say we don't want to have this. Let's say this is the, we don't need to shrink. What we should do? Let's say we don't need to shrink. I want to do the first, the last step. I have to update my objective, right? Let's say my maximum length will be equal to max length and my current window. Every time I'm increasing window end, and I will do shrinking in this part. Well, let's say I did that. And after the while loop I will write here, I'm sure that I have a valid window. So I have to update my objective, which is maximum length. Maximum length will be maximum of my current maximum length and the length of my window. And what is the length of my window? Is window end minus window start plus 1. So we will update this, and after we do all of these guys, we will do return max length. Okay. We need to do is to do the shrinking, which is the most important part of the sliding window problems. But this structure I'm doing in this way, most problems we have kind of in this structure. You need to update the metric, and finally, we are sure that we have a valid window. And so we need to calculate our objective. And so we will say update the objective. Okay. Or, I can, objective, I mean, results, which is here, the maximum length. But how we can handle, update the shrinking? Let's say I went, more than, I need, and the length of my hash map is more than K. So I have to decrease it because it is not a valid, it's not a valid window. So I will write while len of char frequency map is greater than K. Because here we say until, we will say the window is not valid. So it means that, so we need to shrink. We need to shrink it until we have valid window. So how we can shrink? So actually we want to increase the window start, right? But increasing that, we have to update our metric. Because if I increase, let's say here, A will be out of my window, and I have to update my hash map. So before increasing that, I need to update my metric. So that's why I want to write here, let's say, I will say the current char will be equal to S of window start. So I want to put, well, even, let's put this in, make it simpler. It's a naming. Okay. So I put my, the character inside of the char variable, and then we want to decrease it from the map. I will write in a char frag map of char will be -1, and we are sure that we have this inside of the hash map. We decrease it, but let's say if after decreasing it is 0, and we don't want to keep 0, let's say I don't want to keep, let's say here, I don't want to keep, let me bring my, I don't want to keep A0. I should remove it because calculating the number of distinct variables are based on length of my hash map. So whenever I have 0 frequency of any character, I have to remove it. So let's do that. So after decreasing, I have to check if char frequency map at index of char is equal to 0, delete it. We don't need to do that, to keep it, because it will impact my calculations in the when I'm calculating the length of the hash map. So I will delete char frag map at index of char, or key of char. Okay. So actually we updated here all of these 3 lines. We updated our metric, and after that we can shrink our window by 1. But we will do this not only one time, because our objective is not that simple. We have to do all of these operations until we have a valid window. After we pass this while loop, we have a valid window, we can update our objective. And this is the solution for this problem. And as you can see, it is really so similar to the previous one. And the only difference is we have a variable size sliding window. And I said, in this case, we need a while loop. We need a while loop because maybe we will do shrinking can be done more than once. We will do more than once, the shrinking. And also we have advanced data structure. We cannot handle this with a simple variable. As you can see here, this is, if I go with the same color codes, the updating are based on red color, yellow color. So here we are updating our metric, and also here we are updating. All of these are related to updating the metric. And I can write here also, this is also the metric. And the other part, which is really important, is updating the objective, which is we do here, because we have to do this whenever we have a valid window. And as you can see, everything is so similar to each other. And only the calculations, the type of our metric, the data structures we need to update our metric will be changed, and the type of calculations will be changed. Okay. And this part is shrinking. Shrinking, and that's it. And the time complexity, as you can see, we go only once. We traverse once whole string. And so it means that order of n will be time complexity. And what will be the space complexity? Any comment for a space? Any comment? I wanna have a little more interactive, session.
O of k?
O of K, because we always, you know, keep at most K rows, right? K items inside of the hash map. Yes, but you know, actually we go in K plus one and then, you know, pop it, but K plus one in terms of big O will be order of K. Yes, we use for hash map. Perfect. Any comment, any question? I know this question maybe is, you know, really simple for, you know, some of you guys. I don't know the level of the people in the, you know, the meetup, but I don't want to only focus only in the really super hard problems, because really it doesn't happen, you know, in the interviews. If you solve, you know, always the hard problems, you will think that, you know, life is really, you know, really hard. And but you need to solve medium level questions like this. It is not easy question. This is medium level, and this is frequently asked question in especially phone interviews. And also in the, you will see in the next step, next questions, we have a little complicated problems compared to this problem, and they already most frequently asked, and really frequently asked in the, even, you know, the on-site interviews. I really, you know, like to talk about always DP dynamic program problems, the graph problems, but I think it's not, you know, reasonable to solve always that kind of problems, because, you know, in one on-site interview, only one of the problems will be like that. You know, one out of, you know, 4 or 5, 6 problems will be like, you know, graph or DP problem. And all the remainings will be kind of, you know, the binary tree problems, like, you know, sliding window, and we have lots of other patterns. If you focus only on the hard problems, if you have really medium level interview, you will miss that, because you didn't, you know, solve really medium level questions or medium level patterns. Any comment, any question?